In this video, we're going to be talking about Retrieval-Augmented Generation, also known as RAG. So, we're going to talk about the definition, we'll talk about how it works, then the benefits and the applications. Let's dive into it. The RAG, or also known as Retrieval-Augmented Generation, is one of the AI techniques used to improve the performance of large language models. It works by connecting an LLM with external knowledge bases, allowing it to access and use up-to-date domain-specific information before generating a response. So let's break this down on how it works. So this actually solves the problem with the traditional LLM. One of the problems with the traditional LLM is limited knowledge. LLMs are trained on a vast data set of text and code, but their knowledge is static and limited to the cutoff date of their training. They can't access new information or specific private data. Then, because of this limited knowledge, LLMs can sometimes hallucinate or generate incorrect or nonsensical information, especially when asked about things outside of their training data. So, this is one of the benefits of using the RAG. Let's see how it works. So, like we mentioned before, the traditional LLM, that is the non-RAG technique LLMs, what you do is basically pass your prompt into the LLM and it generates. You pass your prompt into the LLM and it generates a response. With the RAG techniques, when you pass a query, it does a search into the knowledge base that you've already provided and it retrieves. This is the retrieval stage. Then it searches the indices for some of the knowledge that matches the query or the questions, and then retrieves the top most relevant context that matches the query, and then send all of these things to the generator, the context awareness generator, before providing an answer. You can see that it has an extra step, which is the retrieval steps. The non-RAG system basically passes the prompt to the LLM and generates a response. But what if the information you are looking for does not exist, or or the LLM has not been trained with that information? So what happens to that? That means the LLM is going to hallucinate. It's going to try to be relevant by giving you incorrect or non-accurate response. But when you use the RAG techniques, you can pass the knowledge base as an extra step. You had it as an extra step, and you can be rest assured that it's going to provide you relevant context. So let's see how the embedding vector similarity works. So when you have your document, your file, your text, your audio, your image, your video, or any of your media, when you want to save it into your knowledge base, it basically converts all your knowledge base into vector, or we call it vector embedding. And then, as an actor, when you are searching for any context, or when you ask a query or a question, it converts your question into also a vector forms. And then it does a similarity check between your knowledge vector and your query vector. It can do this using distance cosine or distance Euclid or any other algorithms. And it calculates the distance between your query vectors and your knowledge vectors and retrieves the most relevant context for you before passing it to the LLM. So this is how the embedding vector similarity search works. What are some of the benefits? Like we mentioned before, it ensures that you have up-to-date or domain-specific data. When you have domain-specific data, a RAG technique is basically the go-to. It also reduces hallucination in large language models by providing you with context-relevant data. It also builds user trust because you'll be assured that it's going to get you accurate answer. And like we already mentioned, it improves relevance to the context. What are some of the applications? One of the applications is that when you have some internal documents or domain specific documents or private documents that the LLM does not publicly have access to, you can use train it on that internal document by using the RAG techniques to retrieve the most relevant context in that document. Another application is for customer support bots. Let's say you have your customer are asking for questions based on the frequently asked question on your blog post or on your business page on your website, right? The LLMs might not have direct access to those questions, but you can use the RAG techniques to retrieve whenever your customer asks a question, you can use the LLM to retrieve the most relevant context in your frequently asked question to provide an answer to your customer using a bot. For legal or medical assistance, you can use it to provide personalized question and answer for the patient because you can pass it to the personal data of your patient or the personal legal records of your clients, and you can use that to provide personalized context to your query. Then for research summarization, you can use it to summarize your research by passing the relevant context to it. Right? For personalized recommendation, you can use it to personalize the recommendation. For example, let's say a movie list or a music or you have something that you want to recommend to your users, and you have each record of your users, and then you can use it to personalize their recommendation based on their personal records. Thank you for listening. In the next video, I'm going to be showing you the practical aspects of implementing a RAG technique using LangChain, OpenAI, and Condrant. I'll be discussing that in my next video. Thank you.